Hello everyone, I'm Ritikya and today I'll demonstrate a zero trust network implementation using Cisco Packet Tracer. Before going on to the simulation, let's understand the concept first. A zero trust is a security model that assumes no user or device is trusted by default. Whether inside or outside, every access request must be verified explicitly. Its key principles include verify explicitly, least privilege access, assume breach, continuous verification, and identity based access. Unlike the traditional networks that trust devices once they are inside the perimeter, zero trust enforces access control at every step. Access is granted based on who the user is, what device they're using, and what are they trying to access. The core principle is to verify explicitly. Always know who is requesting the access, what device they are using, and the resources they want to access. The devices are authenticated, authorized, and continuously verified before any access is allowed. In our demonstration, I focused on three key areas. The very first is device authentication. The verified devices are authenticated first, and then there's an authorized access. The devices are granted access based on their policy. Unverified or non-compliant devices are blocked immediately to prevent any kind of lateral movement. Let's consider a scenario. Let's say a device with a valid certificate tries to access the network. The radius server checks its identity and ensures it is healthy. Once verified, the device is placed into a microsegment and it can only access the resources it is allowed to. It is same as accessing a secure file server. This is least privilege in action. Everything else stay isolated, so even if one device is compromised, the rest of the network stays safe. Discussing a different scenario, which is an unauthorized device. Now imagine a guest device trying to access the secure server. The Radius server either can't verify it or finds it doesn't meet the security requirements. The access is completely blocked and the connection is dropped. This shows that the assume breach principle is an action. No device gets a free pass and the lateral movement is prevented. In our zero trust implementation, these are the all the cases that I have verified. Also, I would like to highlight that triple A based verification capabilities were somehow limited by the Cisco packet tracer simulation environment. So this means my simulation will only highlight the access based list that happens with ACLs. Let's quickly move on to my Cisco packet tracer. This is how my network looks like. We have a core switch in the center connected with two of the servers. On the left hand side, we have an IT management department, which has two PCs and a management printer. Then in the middle, we have a finance department. And then at the right side, we have a journal department. Each department in its own virtual LAN and servers are in a separate protected virtual LAN. The use of trunks is used in this simulation and they allow dynamic VLAN assignment based on the user identity. So the same switch port can serve different virtual LAN depending on who logs in. The Radius server handles authentication, and the web server here provides HTTP and DNS services to test the access control. Without the access control lists, anyone could access everything, which is completely insecure. With the ACLs, the users are restricted to only what they need. This is the true essence of a zero trust. After all the theoretical explanations, let's see how a zero trust network works in action using ACLs. I'll try accessing the admin PC2 from admin PC1. That's the very basic network connection. We can see the received packets and then we can see the ping is successful. Okay, now let's see if a general PC can connect to any of the admin or finance PCs. So we immediately get a response that these hosts are unreachable. This has happened because of the access control list that we've added in the core switch. We can see this the access control list configuration for the general ACLs. It has permitted the TCP and UDP connections while all other IP addresses are denied. This is how we can see that the access control lists are in action. Also, there's one more thing that I would like to highlight is that I wasn't able to use the AAA service that stands for authentication, authorization, and accounting. It's a framework that is used in networking to control and monitor access to resources. We couldn't use that because of the limited Cisco support in Packet Tracer. Since Packet Tracer is a simulation tool and not a full Cisco iOS environment, there were some advanced features that I wasn't able to access. I wasn't able to integrate the 802.1x integration with the dynamic VLAN assignment. So I could only specify the username and passwords for it, which I've done it in the services section of the Radius server. This is the reason why we put the server in action in order to function as the authorization power, while web server is a server that has been accessed by all of them using the ICMP messages, but the radio server right here is there to verify their identity first so that all of them can talk to the web server. What we've done here is create microsegments for each department, enforce least privilege, protect critical servers, and prevent lateral movement if a device is compromised. These are the core principles of zero trust: verifying every access, limiting exposure, and securing critical resources. That was it for my submission. Thank you so much.